Hello students, I welcome you all in the quick solutions of All India AIATS Test Series Medical 2019, and I am here with the chemistry part of test number 1, code ENF. So let us begin with the question number 46. If total number of electrons in a sample of CO2 is 4.4 into 10 to the power 26, then total number of atoms present in the sample is. In this particular question, we have the total number of electrons. So the total number of electrons are given. These are 4.4 into 10 to the power 26. And what we have to calculate here, the total number of the atoms present in the sample. So one thing you should know, if we talk about the one molecule of CO2, it has total 22 electrons, 6 from carbon, 8 into 2, 16 from oxygen. So total 22 electrons are present. With the help of electron, we can calculate the total number of molecules also, because we know that the total number of electron, and we also know that one molecule contains 22 electrons. So total molecules of CO2 present here, total number of molecules of CO2 be equal to 4.4 into 10 raised to the power 26. That should be divided by 22. So these are the total number of molecules, but we need to find out the total number of atoms. The thing to calculate here is the total number of atoms. How can we calculate it? We know that one molecule contains 3 atoms in case of CO2. So definitely the total number of atoms in CO2 would be equal to 4.4 into 10 raised to the power 26 divided by 22 into 3. And if you solve this part, you will find out that the total number of electrons are 6 into 10 raised to the power 25. So which option is correct? Option 2 is the correct option. So I'll write here the answer is option 2. I hope this question is clear to you. Now let's check the next question. Question number 47. Among the following, the ion with maximum polarizing power is. What we need to check here? The maximum polarizing power. And we know that according to Fajan rule, we all know that it is the rule that can describe the polarizing power. The ion with small size and more charge has more polarizing power. And here we have the given options in which different ions are present. Cesium ion, it has larger size and the charge is 1 unit positive charge. Simply chromium ion is also there with 2 unit positive charge. Sodium ion with 1 unit positive charge, and beryllium ion with 2 unit positive charge. We have to find out that ion which has the smallest size, and then we have to check its charge also. So in this case, the ion with the smallest size is beryllium, and the charge is also maximum here. So that is why this is the correct option that we can mark here, option 4. I hope this question is also clear to you. Let's check the next question. Question number 48. Select the correct order against the indicated property. Electron affinity, the order is given, then electronegativity, ionization enthalpy and ionic radii. Along with that, the order of elements is given. Let's check. In the first option, we have electron affinity and the order is also given. If we talk about the given elements, these are the elements of group 16, and the correct order of electron affinity is not given here, Basically the correct order is sulfur, selenium, tellurium, and then here should be oxygen. So in this case the order is not followed, it's wrong. Then electronegativity if we talk about, so this order is also incorrect because the correct order should be for electronegativity it should be fluorine, most electronegative, then oxygen, then nitrogen, and after that there should be phosphorus. After which we have the next is ionization enthalpy. I should mark it also wrong. Then ionization enthalpy, ionization enthalpy of group 13 element does not follow a regular trend, and this trend is given here correctly. First, the maximum ionization enthalpy is there for boron, then thallium, gallium, and aluminum. This is the correct order, but we have to check the next one also. So this was boron, thallium, gallium, and aluminum. After which we have the fourth one is the order of ionic radii. The correct order should be hydride ion, then bromide ion, chloride ion, and after which here should be the fluoride ion. And this is the exceptional case when this hydride ion has the maximum ionic radii. So this is also incorrect. Which option is correct then? Option 3 is the correct option. So the answer for this particular question is option 3. Now after that, let's move on to the next question. Question number 49. The equivalent weight of metal whose 1 gram carbonate on heating gives 0.6 gram of metal oxide is. You have to find out the equivalent weight of metal, and you have 1 gram of its carbonate and it is heated to give you 0.6 gram of metal oxide. So simply this can be calculated with the help of the fact that gram equivalent of carbonate of the metal should be equal to gram equivalent of its oxide. Now how do we calculate the gram equivalent? So if I talk about the carbonate, it can be calculated by its mass divided by its equivalent weight. What would be the equivalent weight of the metal carbonate? That can be calculated with the help of the formula that the equivalent weight of ionic compound is equal to equivalent weight of cation plus equivalent weight of its anion. Simply with the help of this you can calculate. Now it's the turn for the carbonate. We have to find out the equivalent weight. The given mass is 1 gram divided by its equivalent weight. Suppose the metal is E there and we are taking its equivalent mass. Now in this case the carbonate ion is the anion here, and what would be its equivalent weight? Its molecular weight 60 divided by n factor, that is 2. Should be equal to the gram equivalence of oxide. Mass is 0.6, that's given in the question, divided by the equivalent weight of oxide. So equivalent weight of metal plus the equivalent weight of the ion, oxide ion. What is the equivalent weight for that? That is 8, because oxide ion has the oxygen atom with 2 unit negative charge. N factor is 2. And now if you solve this for the value of Em, that is the equivalent weight of metal, that will be 25 gram. And yes, the correct option is option 1. After this, we have the next question, and that is question number 50. Hybridization states of carbon in ethine, graphite and diamond respectively are. In the simple question, we have to just find out the hybridization. So if we talk about ethine, the hybridization is sp. Then for the graphite, that's allotrope of carbon, the hybridization is sp2. And then we have another isotope of carbon, that is diamond, and its hybridization is sp3. And if it is so, let's find out the correct option for ethyne, graphite and diamond. The hybridization is correctly represented in option 2. The answer for this question is also option 2. I hope this question is clear to you.